Hey physics students, Professor Charlie here. This is lab 4. It's going to be, we're going to build something today. We're just going to try to build the apparatus and get it working this week. So you want to build this in a place where you can leave it set up for the week. Because we'll use it next week to do some measurements and some calculations and compare the two. Okay, what do we need? Well, we need some special equipment this time around. Safety glasses, big protractor, force probe. Protractor and force probe are described in the lab syllabus. We need some string. We need some big paper clips and some little paper clips. I don't have enough here. I'm going to have to dig up some more somewhere. Here's some more big paper clips. If you can find one of these things, I don't know what you call them. They're for holding paper together. I'm going to try to use this this week also. This looks like it might be good for something. And some tape and some water bottles. I got Gatorade bottles and some water. I got some water here. Okay, so this is probably one of the more complicated things we're going to put together this semester. So I don't know how it's going to go. We'll see. But let's start out easy. I want to make a couple of weights. I want to make a 3 Newton weight and a 4 Newton weight. And I'm going to make them out of these water bottles. So I'm going to take this water bottle here. And I'm going to take a small paper clip, or a big paper clip. I think I'll take a big paper clip, a little bit stronger. And I'm going to kind of, all these water bottles have a ring around them where the lid was originally stuck. And I'm going to kind of press it out here and get this paper clip so that it's hooked on that ring. Alright, that was easy enough. Now I'm going to fill this with water until it has a weight of 3 newtons. Now, 100 grams has a weight of about a newton, and an ounce is about 30 grams or so. So a newton is going to be the weight of about 3 1/3 ounces of water or so. And this holds, I have my safety, I should have put my safety glasses on. This holds 12 fluid ounces. So this will work. We need about 3 1/3 ounces, so we need about 10 ounces. So this thing's going to be just about full of water to weigh 3 newtons. Alright, so get some water. And I'm going to fill it about, 3 newtons, about 10 ounces. Yeah, all right. Now I'm going to take my force probe. I'm going to put the lid on this first. I'm going to take my force probe and I'm going to hang it on there and see how much it weighs. Go over to my Newton scale. I need these, wow, that is cool. I got it right on 3 newtons. That is awesome. Okay. We're probably going to need this this weight for some other labs, so I'm going to keep it around. I'm going to make it. I'm going to write on it 3 newtons. So now I have a 3 Newton weight, and we'll probably use that in some other labs. And now I want a 4 Newton weight. Well, 4 Newton weight is going to be more than 12 ounces. So it's not going to fit in one of these little bottles. So I'm going to get this bottle here, this bigger bottle, and put a paper clip on it. Let me just step over here and get some more paper clips. So I need, let's see how many ounces this is here. This is, used to be orange Gatorade. This is 20 ounces. So that ought to hold 4 newtons. So 3 1/3 ounces is a newton. So first I'm going to put my paper clip on here so I have a hook. Just kind of squeeze that ring out a little bit. Okay, I put some water in here already. Let's see how much it weighs. It's about 4.2 newtons. You got to hold it still. It's about 4.2 newtons, so I got a little too much water in here. So I'm going to dump some of it out. You could do this by the sink, I guess. You got to hold this really still when you're weighing it. In fact, it's better to hang it on something. If you got something solid, you can hang it on. Four newtons. Excellent. So we need a 3 Newton weight and a 4 Newton weight for this lab. Actually, you know, while we're at it, we might as well, we don't need them for this lab, but we will later on. I'm going to make a 1 Newton weight and a 2 Newton weight also. So I'm going to put a little bit of water in here, about 1/3 of what I got in the, put a paper clip on it. So I can hang it. Here we go. So I'm going to make this into a 1 Newton weight. Well, no, I'm not, because it's right at 2. No, it's not. It's just it's about 1.8 newtons. So I'm just going to add a little bit more water to this and make it into a 2 Newton weight. Make sure it's not hitting the table there. Two newtons. So here's my 2 Newton weight. I'm going to keep it around 2 newtons. Write it on the top. Now I'm going to make a 1 Newton weight. This one's already got a lot of water in it. Got to pour it all out. I'm going to put about half as much water in it as is in this 2. Oh, way too much. All right, put a paper clip on it. Lid on it. This used to be a 3 Newton weight, so I have to, I made a couple of them, so I have to wipe off the 3 newtons. Alright, hang it on here. This is about 1.4 newtons. Still got too much water in it. .2 newtons. Still got too much water in it. Oops. Careful with your force probe. You're going to need it for a bunch of labs. Still heavy. Settle down. Right on. 1 Newton. So, let's get rid of this now. Okay. Who said physics was hard? So we got a 1 Newton weight. 1N. Okay. Up. Sorry about that, physics students. I had a grocery delivery. Anyway, back to building. This is lab 5, I guess. When I first recorded this, I thought it was lab 4, but this is lab 5. It's the Vector Edition lab. Okay, I had to get rid of that white wash table. I put it back in the washroom. It was so unlevel, and the metal top kept warping. So I found this table in the alley, so I'm going to use this for a while. But you need a table with a square corner, like over here. 90-degree corner, some kind of rectangular table. And you need to be able to set this up and leave it set up for the week because we'll use it next week. Okay, where were we? We had made a 3 Newton weight and a 4 Newton weight. Got those. Okay, now we're going to go over to this corner here. Right here. Turn on my camera. And a little delay in my camera. Here I got our stuff that we need. Force probe, protractor, tape, key ring. I take this off of my keychain since I don't go anywhere anymore. And I need a big paper clip. Here's one here. It's kind of all bent up. But first thing I want to do is take this. Now watch carefully because this is complicated. I'm going to take this long end of the paper clip and I'm going to bend it at 90 degrees to the paper clip. Like this. Make kind of a vertical, well, just make a pin sticking up there. Then I'm going to take the rest of the paper clip and bend it out like this. Okay. And I want this to be close to 90 degrees here, this little edge here, so I might have to bend it a couple of times. And then about 6 inches from each corner here, about 6 inches here and about 6 inches here, I'm going to align the pin like this and tape it down to the table, trying to get the pin going straight up from the table. So let's try to get a close-up of that. Here's a side view. Kind of upside down here. What? My camera's being kind of unruly this morning. See how that goes? And I'm going to tape it down there. I'm going to have to try to figure out how to get Bixby off this phone before it drives me nuts. Alright, so I'm going to take some tape. Tape it down real good. Alright. It's going to have to sustain some force here. So I want to make sure I got my tape ball down real well. I might put some like this too. Okay, then I'm going to take my protractor, and the protractor's got a hole in it, of course, where the center of the protractor is. I'm going to slide that hole down the paper clip, so the paper clip's sticking straight up from the hole. Now I want to have this side of the protractor kind of parallel with this side of the table. So I'll just eyeball that. Then I'm going to, get this paper clip out from underneath there. Then I'm going to tape the protractor down so it doesn't move. I'm going to put a little tape over here because I won't need to read those angles too much. Then I'm going to put a piece of tape over there. I won't need to read those angles. And then I'm going to put a little piece of paper, a little piece of tape right about 90 degrees or so, just to make sure it's secure. Okay, moving right along, I'm going to take my key ring right here and put it over the pin. See the situation so far? Good. All right. Now I'm going to take a couple pieces of string, about a foot long. A couple pieces of string about a foot long, and put a paper clip on each end. And I'm going to hang a paper clip here and hang the string over the edge of the table. And then I'm going to hang the 4 Newton weight on there. So that's why that paper clip has to be tied down pretty well. So I got the 4 Newton weight hanging right there. It's hanging off the edge of the table. Okay, maybe you're starting to get the idea here. Here's another piece of string about a foot long with a paper clip at each end. And I'm going to hang that over here on the key ring. I want to keep the paper clips from binding on the table. I'm going to hang that on down this side of the table. And I'm going to hang the 3 Newton weight on there. So if we go down here and look, there's my hanging weight. There's my other hanging weight off this edge of the table. And maybe you're starting to get the idea here. Ideally, I would have a 4 Newton force pulling on the key ring in this direction, and I'd have a 3 Newton force pulling on the key ring in this direction. So I have a combination of a 3 Newton force and a 4 Newton force acting at 90 degrees on the key ring. Okay. I think you can see a problem here. The problem is with these edges right here. There's a good deal of friction between the string and the table right here. And that's kind of messing up the simple description I just gave of this, because that friction there is holding up this, doing a little bit to hold up this 4 Newton weight. And so it's making this force a little bit less than 4 Newtons, and this force a little bit less than 3 Newtons. And that's a problem with this lab. When we do this experiment on campus, we have pulleys here. I don't know about you, but I don't have any pulleys laying around the house, and I don't want to buy any just for one experiment. So we need to work on that. We need to think about that. But right now we're going to first get the idea of this experiment. What I want to do is I want to use my force probe to measure how much force it takes for me to cancel out these two. So these two are summing together like vectors and exerting a force on this ring. And I want to use my force probe to measure what is the direction and magnitude of the force I need to cancel these out. So I'm going to take my force probe and I'm going to hook it on the key ring. I'm going to hook it on the key ring and I'm going to pull. I want to make sure I'm not biting, not too much stuff is rubbing here. I want to pull until I get that key ring about centered. And then I want to look and see, I got my force probe going the wrong way because the scale is down. I want to see how much force it's going to take for me to get this balanced, to hold this balanced. All right, you see how I done that? Now, the measurement I'm going to make is how much force is my force probe reading right now, and at what angle is it reading? That's what I'm going to look at. I'm going to look eye down here, eye straight down, and read the angle on the protractor. Okay, that's the idea of this lab. Now, let me get a pen. Let's see if this pen is right. So we have a coordinate system here. This is the third quadrant. This is the fourth quadrant here. Up here is the where I have the angle to measure protractors. That's the first quadrant. And over here is the second quadrant. So this is the negative y direction. Over here is the negative x direction. Here's the positive x direction over here. And here's the positive y direction up here. So there's my coordinate system. You don't need to write on your table. That's just for illustration purposes. For me, once again, I got this table in the alley, so I can do anything with it I want. So right now I can feel that. Boy, I can feel the friction in these corners right here. So I want you to think about that this week, ways to get around that. But here's one thing I'm going to do. I'm going to take a couple of pens. Just, ballpoint pens I got laying around here. And I'm going to, I want to make kind of a rounded edge here. So I'm going to set this pen so it's kind of lifting up the string, and I'm going to tape it up. You can have calamities like that. I'm going to tape it so that it is giving a little bit smoother surface for the string to rest on. And so that the string isn't touching my table. I think that might help a little bit. This is what I was thinking about when I said fishing line would be really good for this. Fishing line is designed to have not very much friction. So I'm going to do that down here too. Take this pen there. Much smoother. I can still hear it squeaking though. It's still rubbing on the side of the table over here, so I want to get that out a little bit. I think you can probably even hear it squeaking some. You know, a little lubrication, maybe a little, get this going straight out here. A little lubrication might help, a little cooking oil or something. Graphite. All right, now, to find out how well your apparatus is working, I know that a 3 Newton force and a 4 Newton force at right angles add up to a 5 Newton force, because 3 squared is 9 plus 4 squared is 16. Add them together and you get 25, and the square root of 25 is 5. So you should know enough about vectors now to see what I'm talking about. A 3 Newton force and a 4 Newton force add up to a 5 Newton force. And the angle that they would be, if I add these two vectors together, I'll get a vector that's making about a, I think a 53 or 54 degree angle or so with the x-axis going in this direction. So the force that's going to cancel them out is going to be 180 degrees opposite that over here in the first quadrant. 54 degrees. 53 or 54, I can't remember. Whatever the arctangent is of 4/3. Hey Google, what's the arctangent of 4/3?
On the website stackexchange.com, they say, so tan minus 1, 4/3, means the angle, x, so that tanks equals 4/3. Do you want a little more context?
No, Google. She's not following me. Hey Google, what is the value of the... Hey Google, what is the value of the arctangent of 1.333?
Sorry, I don't have any information about that, but I found something else. Do you want to know what is arctan on a calculator?
No. Okay, Google's not helping me much today, and I don't have a calculator with me, but I think it's around 54 degrees or so. So I'm going to hook my force probe up here.
I think you want to get the weather forecast for today.
No, I do not. Oh, Google, stop. I don't need the weather forecast for today. Okay.
Today in St. Louis, it'll be mostly
sunny. Hey Google, stop. All right. Back to this. So I'm going to kind of pull on this and try to balance it. You know, moving this around a little bit. And boy, there's a big variation here because of the friction. And I don't have enough light. I'm going to turn on my flash. No, I don't want to do that. I'm reading just a little bit more than I'm reading about 5.2 newtons. That's pretty good. And then I'm going to look at the angle. I'm try to look at the angle here. You see, you're not going to be able to read the angle very precisely. You're just going to have to guesstimate where the center of that is. What I'm going to do right now is I'm going to try so I can get. It's good to have a couple pairs of hands for this, obviously. I'm going to try to tape down my force probe so that I can get it set and then try to read the angle. So I'm going to kind of jiggle it around here. Then I'm going to try to tape this down. Well, I could really use another set of hands right now. Here's what I'm going to do. I'm going to put a bunch of tape on it. Get it balanced. And then try to tape it down. Like I said, if you can get your lab assistant to help you out here, be very good. Well, that's about as good as I can get right now. I want to make sure my friction is reduced here. Looks like I gotta move it a little bit more. Okay, at least I can hold it with one hand now. So I'm seeing about 4.5 newtons here, and the angle, it's too dark right now for me to read the angle. And no flashlight. Let me plug in this light here, maybe. Ah, yes. I have my protractor upside down. Oh, no, there. I'm reading about a little less than 60 degrees. And yeah. I'm reading about 5 newtons, a little bit more than 50 degrees. This angle right here is about a little more than 50 degrees. So that's cool. So this is working pretty good. Once again, we have a friction problem here. And it's good to have 4 hands to work on this experiment. And we might think before next week better ways to reduce the friction. Like I said, if anybody's got fishing line out there, I'd really be interested to hear how it works. Certainly there's someone in the class that has either fishes or lives with a fishing person. Okay, all you got to do then for this week is to get it set up and try to get a picture, a top view picture of your force probe balancing out these 2 weights, and a side view picture, 2 pictures, a side view of your weights hanging from the table. Then pick up the weights so you're not pulling on your paperclip pin all week, and set them up here. We'll need them for next week because we're going to set up some different vectors, not at 90 degrees, and compare the vector addition results we get by doing calculations with vector addition and the measurement that we get. Okay, that's all you got to do this week. Hey, physics students. A little addition to the lab. I was able to find this roll of fishing line in my house. My house is reaching its 100th birthday. It's actually quite a historic house. In a recent documentary on the Hill neighborhood, it was mentioned in particular, because right where I'm standing during Prohibition, this area was a distributing location for illegal booze. There used to be a garage over there down here in the basement, and people would pull their car in from the street and get it loaded up with liquor. Anyway, so I enjoy working here. That's why the floors are so unlevel. Even though I got a better table, I still had to level this table. The basement's considerably unlevel. So anyway, I tried this fishing line, and I think it works better. So right here I've got, the fishing line is very difficult to see. Well, you can't see it in this picture. But I'm going to pull this out so it's balanced. Try to find the angle that I need to balance it. And that angle looks to be about, you can't see too well on this, somewhere around 50 or 60 degrees. And the force is measuring about 5 newtons. So you can kind of fine tune this to make sure it's centered, kind of move it around a little bit. So we're not going to be able to get real precise measurements in our to compare with calculations. So don't be expecting a really small % error necessarily, depending on how good your device is. And that's it. Once again, I'm going to lift up the weights so they're not hanging on my apparatus all week. You know, if you ask the man on the street, how much force do I need to balance if two people, well, you couldn't say 3 newtons and 4 newtons because they wouldn't know what a newton was. But if you said I had 2 people pushing an object or pulling an object with a 3 pound force and a 4 pound force, and you ask a person on the street, how much force would I need to balance that out from those people? They'd say 7 newtons. And that's why we don't let the man on the street design buildings or airplanes or actually even be doctors or physical therapists or anything else for that matter. Because it depends on the angle between the two. Here we've got a 3 Newton force and a 4 Newton force that are being balanced by a 5 Newton force. Depending on what angle they're at, they could, 3 Newton force and a 4 Newton force can add up to anything from 1 Newton to 7 Newtons. If they're going in the same direction that you get the most, that's 7 Newtons. If they're going in opposite directions, you'd get 1 Newton. Anyway, so that's why we study forces, just so we know a little bit what we're talking about out there in the world. And that's it for this week.